What is data visualization anyway, and why bother? I'm going to use some material from this textbook by Tamara Munzner, Visualization, Analysis, and Design. So the following slides some of them are by Tamara Munzner. According to Tamara Munzner in this book, computer-based visualization systems provide visual representations of data sets designed to help people carry out tasks more effectively than they would be able to without visual representations. Visualization is suitable when there is a need to augment human capabilities rather than replace people with computational decision-making methods. It's very human-oriented. So you don't need visualization when you have a fully automatic solution for doing some task. And machine learning comes to mind. Machine learning solves a lot of problems that you don't need visualization for. But many analysis problems are ill-specified. You don't know exactly what questions to ask in advance. That's one place where visualization is really useful. Possibilities for visualization products, long-term use for end users. For example, you build a tool that an organization is going to use for years to come. Presentation of known results, as in coming up with a figure for a paper that you're going to present, or a journal article that you're writing, or a news article. A stepping stone to better understanding requirements before developing models. And what she means there is computer-based models like statistical models or machine learning models. Before you get into developing those very specific things, visualization is a good stepping stone to just explore the data that you have on hand. To help developers of automatic solutions refine or debug those systems. And to help end users of automatic solutions verify those automatic solutions and build trust in those systems. So this is Tamara Munzner's take on why visualize data. And I want to emphasize that it's very human-oriented. It's to help people carry out tasks that they can carry out enabled by data sets, concrete data that's on hand. So why use an external representation? Computer-based visualization systems provide visual representations. The idea is to replace cognition with perception. And I think back to this quote that I can never get right by Richard Feynman. And somebody asked Richard Feynman, the famous physicist, how do you do your work? How do you come up with your amazing ideas? And he's like, I think on paper. And I don't know if it's word for word correct, but the person interviewing him said, what do you mean you think on paper? Like you think of it and then you write it down? And he's like, no. The thinking happens on the paper. My thought process has expanded outside of my head into a physical representation of the ideas. And it's that feedback loop between your head and this external representation that makes your cognition augmented. So that, I think, is really the core of what visualization is about. It's using computers and displays of graphics to augment what you could do without it, meaning with raw tables or just by writing things on paper or mathematical models. So that's why use an external representation. And I want to give some examples to demonstrate this. So let's say you want to know which country on Earth has the most Hindus, the most people who adhere to the Hindu religion. And I found this interesting data set from the Pew Foundation about religion by country, and these are the top 20 most populous countries. So it's a data table that has 161 rows. Each row is a unique combination of country and religion with the count for that combination. And so you could read through each of these numbers and say, okay, in China, there are this many Christians, and there are this many Muslims, or there are this many Hindus. And you could read through the list and try to figure out, which country has the most Hindus. And the point is, by looking at this table and trying to read each of these numbers and remember what they were in your head, and then go back and consult your memory of what the other numbers are as you read through this, it's a very cognitive intensive activity. It's using a lot of your brain power. But the point of visualization is to offload that brain power to your eyes and your visual perception system, because you can perceive so much with your eyes. So here's a visualization of that data set. It's a stacked bar chart where the religions are along the left and the colors represent the different religions. Looking at it like this, you can phrase the question, which country has the most Hindus, as a visual question. You can convert that from concepts to questions about shapes on the screen. So instead of asking which country has the most Hindus, you need to ask yourself, which red square is the biggest? And so by looking at this, you can see easily the biggest red square, and it's in India. So that's just a static visualization. You can do so much more when you start adding interactivity, such as hovering over these entries in the color legend to see the highlighted corresponding colors in the graphic. So this is a form of interaction that I feel is underutilized. Every time you have a visualization with a color legend, you could add this interaction, or the authors of the graphic could add this interaction, and it would make these tasks a lot quicker. Then you could say, okay, I want to look at Hindus and hover over that, and it pops out very quickly. And so with that hovering interaction, you can see, oh yeah, India has the most Hindus, but there are other countries in this top 20 list that do have a significant number of Hindus, specifically Bangladesh. And then here's another interaction technique called Tooltips, where you hover over these rectangles and you get more details on demand. This is also a technique of interaction that you could apply to pretty much any visualization. By hovering, getting more information. It's called Tooltips. And then what I love about visualization is it lets you step back too. You can just, without any questions in mind, you could just look at this and ponder what it says. One thing that surprises me about this particular visualization is that some countries are very much majority religion, as in most of the people are one religion in these countries. Like what pops out is Turkey, Iran, and Egypt, or you could say Muslim majority. Bangladesh, Pakistan, Indonesia. Nigeria is split down the middle between Muslim and Christian. I find that fascinating. And there are some Christian majority countries, Mexico, Philippines, United States, but not exactly. Like there's a huge portion of unaffiliated in the United States. But you could go on and on and on and just look at this and interact with it and ask new questions that you wouldn't have thought about before without seeing the visualization. And that's another powerful aspect of visualization. It brings up questions that you wouldn't know to ask if you didn't do the first step of visualizing the data. There we have it. That's what data visualization is and why bother.